Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 15, 2025, just yesterday. It introduces a model that can generate controllable, minute-scale videos with strong temporal consistency and visual quality, supporting continuous video generation lasting up to 5 minutes. The paper is titled LongVie 2, Multimodal, Controllable, Ultra-Long Video World Model, and as we will see later, the implications for unified video world modeling are pretty exciting. Also, the authors shared a GitHub repo where you get the full LongVie 2 codebase, ready to run training and inference scripts, config files for the 14B setup, a downloader for base and LongVie weights, plus utility scripts for extracting and converting depth, trajectories, and refined captions for controllable ultra-long video generation. Figure 1 illustrates how LongVie 2 turns a single input image plus structured guidance into a long, coherent video lasting several minutes. The left block shows world-level guidance, where dense control means depth maps that describe scene geometry, and sparse control means colored points that track key objects over time. The central rows of frames demonstrate that these controls let the system keep the car, pedestrian, or skateboarder consistent, while the background evolves smoothly. The bottom row highlights that this process repeats autoregressively, so the model can extend the video far beyond 1 minute while preserving style and scene layout. Figure 2 illustrates why long video generation is hard in the first place. The top row shows a pirate ship scene that starts sharp and controllable at 0 seconds, but quickly becomes distorted and chaotic by 15 seconds, which signals both visual and semantic drift. The bottom row repeats this pattern for a moonlit lakeside house, where the cozy cabin view dissolves into a blurry, unrecognizable landscape. Together, these sequences highlight that existing video world models lose fidelity and temporal consistency as the generated duration increases. Figure 3 explains how LongVie 2 actually turns controls and history into a coherent long video. The left column shows dense and sparse control signals flowing through global normalization, which keeps guidance from different clips on the same scale. The central panel illustrates Stage 1 and Stage 3 inputs, where depth video, point video, text, and tail frames all condition the diffusion process. On the right, a trainable multimodal control module steers a mostly frozen denoising backbone, so the generated clip stays faithful to the scene layout while remaining consistent with previous clips. Table 1 summarizes how LongVie 2 stacks up against prior video and world models on the Long versus General Bench dataset. The table shows that LongVie 2 scores the best or second best across visual quality, controllability, and temporal consistency, so it delivers both sharp frames and stable motion. Structural similarity, or SSIM, measures how closely generated frames match the reference, while LPIPS measures perceptual distance that correlates with human judgment. LongVie 2 achieves the highest structural similarity and the lowest perceptual distance, which indicates very accurate and natural-looking control. The subject and background consistency scores are also highest, confirming that key objects and environments remain coherent over long durations. Figure 8 shows that the generated videos stay sharp and coherent even after more than 2 minutes of continuous playback. The first row of kitchen faucet shots keeps the scene layout and lighting stable, while the water and hand motions evolve naturally over time. The second row of driving footage preserves the car, road, and distant mountains, so the motion feels like a single long journey rather than stitched clips. The third row of corridor scenes maintains character identity and interior lighting, which highlights strong temporal consistency in darker, more complex environments. Table 3 makes the main point that each extra training stage measurably improves every aspect of long video generation. The top header divides metrics into quality, controllability, and temporal consistency, which together capture sharpness, faithful control, and stable motion over time. The rows show that adding control learning already boosts all scores, degradation adaptation improves them further, and history context delivers the best overall numbers. In other words, the full stage recipe is essential for the strongest world model behavior. So, the big message is that LongVie 2 turns short clip diffusion models into a controllable video world model that stays sharp and consistent over several minutes. The staged recipe, with multimodal control, degradation awareness, and history guidance, really matters for stability. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.